6.3, number 21. How much must be deposited at the beginning of each year in an account that pays 8% compounded annually so that the account will contain $24,000 at the end of 5 years? Okay. So first thing you want to try to do is determine what type of annuity this is, and since it says beginning, that means this is due. So you see the keyword beginning, that tells you it's annuity due, and so that means it accrues an extra interest for each period. And so that adjusts the formula you're going to use in a second. Next, you want to see what other information you have here. So you see that you are given the future value of $24,000. So you're trying to get up to $24,000. It's asking how much must be deposited, so you don't know the payment. And it says that the interest rate is 8%, and this is compounded annually. Okay, so, and you have a time period of 5 years. Okay, so we know T is 5. Because this is annually, we know our period interest is 0.08. It's the same because it's divided by 1. And we're trying to find the payment. So, and again, we have annuity due because we see the keyword of the payments are made at the beginning of the periods. So, formula for this is the future value equals the payments times 1 plus the interest rate to the n minus 1 over the interest rate of the period. And now it's different because this is due, is you have an additional interest for each period. So you have this additional factor here. All right, so we're trying to find payment. So what we're going to do is we need this whole thing here now is the growth factor. And so what we want to do is divide by it to get R by itself. So we get R is the future value divided by all this stuff. It's I there. 1 plus I. Okay. And so we know all this information here. And so we're just ready to go. So compute this growth factor and then divide by divide the future value by that number. Okay, so we have our payment equals 24,000 divided by 1 plus 0.8, and this is to the fifth because we have 5 years. It's 1 over 0.08 there. And then times 1 plus 0.08. Okay. So 1.08 to the fifth minus 1 over 0.08. And again, I'm just going to be computing what this stuff is here. I guess I should. And then dividing the future value by it. 1.08 to the fifth. So we have 1.469. Again, keep all the decimals in your internal calculation, minus 1, 0.08, and then multiply this by 1.08. So 0.469, 0.08. Okay, so that gives 5.866, a bunch of decimals, times 1.08. And so this is 6.3359. Okay, so this number represents the quantity in the denominator, which is the amount that our payments are growing by in the annuity. So our payment is going to be 24,000 divided by this result. So 24,000 divided by, and so 3,787, 9212. Okay. Now we need to round at this stage because we're set to have the final answer, and so we're going to round to 392.